Hello guys, today we're going to take a look at this NRF24 module. It's the radio module that I'm using in most of my tractors now, and as a result a lot of people have asked me about making a tutorial just about getting started with it. So that's what I'm going to do today. I'm going to do a pretty simple tutorial just to send commands from the controller to a receiver. So it might look like the controller here is very complex, but I'm not actually using the entire controller. I'm just using part of it, and I'm just doing that because it's a lot easier for me to just use what I have here instead of making another board with a joystick and an Arduino and a radio module. So all that's actually going to happen in this tutorial is we'll be able to control a motor with our joystick forward and back, and we're going to switch on an LED by pushing in the joystick. So that's all that's been used. So all you need for your controller end of the circuit is the joystick, an Arduino Pro Mini and a radio module. You don't need anything else for the controller. So first things first, this video is accompanying a post in the blog, so if you check the description below you'll see a link to the blog, and there you'll find the different circuit diagrams and everything else that you'll need, like parts list, stuff like that you need to do this tutorial. The second thing is that I've posted the code for this in the forum, and my idea there is that this is a very simple basic code just to get you started, and maybe you guys will upgrade the code and then re-upload your improved versions to the forum as well, and then whenever anyone clicks on the link they'll find your code, which should be the most recent or the most up to date. One thing in the code that someone should try to solve if they can is to get the servo library, or get a servo library to work with this configuration, because at the minute if you use the NRF24 library and the servo library, they both try to use the same timer on the Arduino, and as a result your code won't compile and you won't be able to program your Arduino. So I'm not going to use a servo in this because I haven't tested it. I don't need to do that for the RC tractors because I have a second Arduino in the body of the tractor. I have one in the cab and one in the body, and the one in the body controls the servo, the one in the cab controls the radio, so I don't actually need to overcome that problem. I'm going to focus on the code for the two Arduinos in the tractor module and get that full tractor code working properly. That's my main focus at the minute. So if someone else has the time to check out how to get the servo commands working on an Arduino that already has an NRF24 module, you can post it in the forum, and that way it'll help everyone else out too. So all we need is the joystick, the Arduino Pro Mini and the NRF24 module, and here is the wiring diagram for that. The Arduinos we're using have to be 3.3 volt Arduinos, and if you see this little solder jumper here, so this Arduino can select between 3.3 volts or 5 volts, so you need to get one that you can set to 3.3 volts or that already comes 3.3 volts. That's because the NRF24 module is 3.3 volt sensitive, so the regulator in this can regulate the 3.3 volts that we need for our NRF24 module. So for the receiver end of things, we need our Arduino and our NRF24 module. I've taken a shortcut here. I already had an NRF24 module and an Arduino made up just for testing, so that's fine there. That's just it already wired. We need a TB6612FNG motor driver. You need a DC motor, just a normal DC motor. You also need an LED and a resistor. I have two here in parallel just to give me a lower resistance. And of course you need your battery. So I'm using a 3.7 volt battery. And you'll also need a few wires to connect everything up. So here's the circuit diagram for the receiver. Okay, so here's the receiver code. First thing we have here is the pin assignments, and at this point you should have those wired up correctly. You can check the blog post for the wiring diagrams. Next thing then is the ID for the vehicle that we're using, and I've just basically taken most of this code from the code for one of my RC tractors. So I decided to include this ID part just so that you could get a bit of experience with it. This actually is JD83 in hex. That's all that means. And then we need to have a few variables here that we can store our data as we proceed through the program. And the final thing then is to include a couple of libraries and create our NRF24 object that we're going to use every time we need to send a command to our NRF24 module. Then after that we go into the setup loop here. So we want to set pin 4 as an output because that's going to be our LED pin, and then we need to initialize our NRF24 module. And now we're into the main loop. So the first thing we need to do is test that check do we have any data available on our NRF24, has it received any data, and if it has, we'll create a buffer which is an array of 11 bytes here, and then we'll put the data that we've received into that buffer, so we'll store it there. And then the next thing we want to do is check that this is the correct data packet for this tractor. So we check the first 4 values of the buffer, or the first 4 values of the array that we're after storing the data in. We check that they match our vehicle ID, and if they do, we store all the rest of the values in here as a command value and 6 data values. Now that we know that's the right data for this tractor, we can use the data. Now, normally I test the command value and use the data depending on what command was received, but I've made this a little bit simpler just for this little tutorial. So we go straight away into the motor control here, and what we're going to use for the motor control is data value 5, and basically our value for the motor is going to be a single byte, which is going to be somewhere between 0 and 255. We're going to get a number somewhere between 0 and 255. The middle of that is 127.5. So if you imagine, that's where your joystick is completely centered. So we want to create a little buffer either side of the center of the joystick, so that the joystick, or so that the tractor isn't moving just every time the joystick gets a little shake or anything. So we're taking 7.5 bits either side. So this first if function tests for a value below 120, and then it maps that value from, so our value is going to be somewhere from 120 to 0 as we pull back our joystick, and we're going to map that from 0 to 255 for our pulse width modulation. That will give us somewhere, well, 0 will give us 0%, and 255 will give us 100% duty cycle on our pulse width modulation. So now that we've created our pulse width modulation value, we need to set a direction. So we set pin 6 high and pin 7 low. In the next one we test for values above 135 and map them from 0 to 255, and then we set the pin 7 high and pin 6 low, so they're the opposite way around, because that will give us the opposite direction. The final thing then, if our value isn't within either of these ranges, it has to be between them. So we note that we don't want the tractor to move then, so we set the pulse width modulation to 0%, and we set the 2 digital pins low, although you don't really need to do that, but it will 100% make sure that the tractor doesn't move. The final thing then is just to set the LED, and that's if data value 6 is equal to 1, we set it high. If it's not, we set it low, and that turns the LED off. That's just as simple as that. So that's fairly simple code. Sorry I'm rushing through this, but the screen capture software is not very good. Okay, now we're looking at the controller code. A lot of this is the same. We have your pin assignment again. We need to define our variables. They're slightly different than the other ones, just because we're doing different things. Our libraries, create the object for the NRF24 module. set up some arrays to store our data. That's fairly straightforward again. In our setup, we're setting the pin to be an input this time, and we want it to be a pull up. So because we've set that, it's going to always be at VCC, and our push button is going to connect it to ground and pull it low. So pin 7 is normally going to be high because of this, and our push button is connected to ground, so it's going to pull it low. Then we initialize our radio again. We just set up some initial data values here, but we don't really need this because we're going to set them as we go through the code anyway. So far it's pretty much been the same as the receiver code, but now when we get into the loop here, you see that we're actually calling 3 different functions instead of just running through the code like we did previously. So the first function is to check the vehicle ID. Now this is to do with buttons or whatever you've used to set or to choose your vehicle. So maybe you use the touchscreen LCD to select what vehicle you want to drive. That would happen in here. Because this is only a simple tutorial, I'm just putting the commands straight to JD83. So there's actually no selecting of the vehicle ID going on here, but this is where you would normally do it. Once we've set the vehicle ID, we need to check the button here. So we do a digital read on pin 7, and if pin 7 is low, then we check if the headlights are on or off. In this case they're off because it's a 0, so we set it to 1 to turn them on, or if they had been on, which would be a 1, we turn them off. Now this is something people forget here. It's important. This is a loop to catch the bounce. So what that is when you push the button down, if you don't have this loop in, your code is going to continually turn it on and off and on and off and on and off thousands of times before you release the button. Now you think that you're pushing it on and off really quickly, but you're not in terms of how fast this microcontroller can process that. So you need to catch that, and what you do is you just wait inside this loop until your finger is released from the button. So once the button goes high again, then you continue, you send the data, and then you leave the loop. The final thing to do then is to check the potentiometers. Now you do that by doing an analog read, and you get a value between 0 and 1024. I think that's too much information, so I map that from 0 to 255, or FF, which is just hex for 255. Now the reason I do that is, if you split that in half, right, and imagine your joystick is going forward, so you're going from 128 to 255, that's 128 data points roughly. That's more than enough variation on your speed control. You don't need 1024 variations of your speed, because you're never going to see that in reality. And beside that, the pulse width modulation is only from 0 to 255, so 255 is the only resolution you're going to get anyway, so it doesn't really matter. You save data by just getting a value to 255. So then we check to make sure that the joystick has actually moved, because we don't want to send, or we don't want to constantly be sending data, because we might interfere with other controllers and other tractors. I'm not 100% certain about this yet, so I just put it in to be safe. I haven't got any other controllers and tractors to test, so as soon as I do, I'll be able to check if that's the case. Hopefully we'll be able to use multiple controllers and multiple tractors without any interference. And the final function is just to send the data. It's pretty simple, pretty straightforward. Okay, so now we have everything hooked up here. We have the motor going to the motor driver, going to the Arduino, and our radio module is connected to the Arduino, and also our LED via the resistor is connected to the Arduino. So that's all fine. This side, joystick, Arduino, radio module, fine. So now we'll test out the motor driver first. So the motor here should have proportional control. As we move the joystick forward, the motor should start to move slowly, and the further we go forward, it should get faster. So there we go, starting to move, and gets faster. Slow back down, and we can reverse direction. And we have nice proportional control over the motor there. That's perfect for our tractor. We need to be able to move nice and slowly so that we can get a good bit of control. Okay, the final thing to look at is our LED over here. So you should see that turn red when I push the button. So because I'm doing this so slowly, you can see that occasionally the LED is not turning on or off, and I'm pretty sure that is because we're losing that data packet. I'm not just getting it to recreate at the minute, but if you do it enough times, you're going to miss the odd data packet. Like there, right, we missed it that time, and we missed it again, and there it is. So you might notice that with LEDs and stuff like that, that's because we're using these cheap radio modules. If you're using an XB or something like that, that's expensive and has all these kind of fail-safes in the code to prevent all that, you wouldn't notice that. And we can probably come up with some fail-safes ourselves to make sure that we send the data, or we could just tell the receiver to send a push button signal 5 times or something like that, so that, you know, the chances of all 5 data packets missing would be pretty small. So maybe you could just tell it to send 5 packets in a row with the same data. But you're not normally going to notice this, because every slight adjustment you make to the joysticks is going to cause that to send a huge amount of data. Just to show you what I mean, there's a small LED in here. Now when I push the push button, you should see that blink once. So you've seen that LED flash there. I'll do it again. There's the LED, okay? So that means that we've sent 1 data packet. So when I move the joystick, you'll see that that LED is pretty much on constant. And that is because every time we move the joystick by 1 data point, 1 measurement of the voltage, 1 data point, it is sending a command, and there is 128 different data points between this point and full speed. So, you know, we're going to send all those data points, and the chances of your model going out of control with that kind of data are pretty slim when you're sending that many commands. So what you could possibly do to get your button to work properly, or to work every time, would be to send maybe 5 data packets in a row, and chances are that, well, probably 4 out of 5 are going to arrive, but you know, you'd just be making the thing safe for yourself. So when we're making an adjustment with the joystick, it's unlikely that we're going to lose data packets, but when you're doing a single push button action like that, there is quite a possibility that you lose that data packet. So you might just want to maybe send the same packet 5 times when you do a single push button. You don't really need that with the joystick, because you're sending so many data points that the chances of you missing enough that it will be noticeable are microscopic. Even for a human to hold the joystick in one position is pretty unlikely. I can see the LED is flashing there, even though I'm trying to hold it in the one position, and that's because you're shaking a slight little amount. Now, it's only going to look like a couple of millivolts to the Arduino, but it measures that as a change, and then it sends more data to match that. So your motor speed's going to match that slight variation, but you probably won't see that in the model, but still it's going to send that data. So that's why, from a control point of view, from driving and steering, you're unlikely to really notice that issue. But with LEDs, where you're pushing the button once, you're probably going to notice that. So in the main tractor code, I'll probably put a loop of maybe 5 times sending the same command to turn on the LEDs, and that should get rid of that problem. And if that doesn't solve it, maybe we'll go to 10 times, and we'll see if that'll solve it. So you could make it a little bit more complicated, where this sends the command and then waits for one back from the receiver. But the problem with that is that you send the command and you have to wait a certain amount of time for the returned signal. But if this one has lost the data packet, then you have to wait that time, then send it again. And if this one maybe gets it, but then the data packet is lost on the way back to the controller, you have to wait here again, send it again, and you could end up losing quite a noticeable amount of time waiting for these packets to go back and forward. So personally I think it's better to send the 5 commands for the LED, and if that doesn't turn the LED on, well, it's not a big deal, it's only the LED. You won't lose control of your motor. It'll send the 5 commands pretty quickly, and you probably won't notice that on your motor controls. But if you get caught in a loop of delays here waiting for commands coming back and forward, you might start to notice this on your tractor, or your tractor might drive into something. You might lose so much time that it's noticeable from the control of the tractor point of view. Another point about this is the motor update and the LED update are all on the same data packet. So if I flick I've switched the button there, but the LED hasn't come on. Okay, so obviously I lost that data packet. But as soon as I go to move the motor, so you seen the LED come on there when I moved the joystick. That's because each data packet that this is sending, that has the information for the motor, also has the information for the LED. So when I done this, it sent off maybe 20 data packets. Each of those had the command to turn on the LED. Now some of those data packets might have got lost, but we didn't notice it on the motor. There's nothing noticeable missing there, and the first data packet that does arrive, that LED is going to come on. So what I'm saying is the LEDs should be second place to the drive controls. You don't want to delay the drive controls and lose control of your motors. You want the drive to be the number one priority, followed by the LEDs. So that's all there is to the simple tutorial. There was quite a few people asking for that because they want a kind of stepping stone before I give you the full tractor code, which I haven't finished yet. I'm working on that at the minute. So this was just so you could get an idea how to communicate between two Arduinos with the NRF24 modules. Now the tractor code is much more complicated because it has all these joysticks. There's I'm thinking about a touch screen on the controller, and you have different potentiometers, different switches. So that's all very complicated from the controller point of view. Then when you get to the tractor, you have a huge array of LEDs. You have two Arduinos. You're trying to control drive motors, servos, talk to the trailers. So there's a lot of stuff going on in the tractor, and rightly some of you suggested that I do a stepping stone kind of tutorial first, so that you can get an idea of how this works before you get overwhelmed by huge long code that's in the tractor. And the tractor code is very long, and it is kind of complicated, but it's basically this code repeated. You know, what we've done here for this joystick, we just have that 6 times. We've done for the button, we just have that for however many buttons there is. So, you know, it's fairly straightforward. It's just that it's quite long because there's a lot of information in it. I'm working on the main RC tractor code at the minute. I have the John Deere 8360 RT as a test bed, and the Massey 8680 I'm working on getting that going too. So while I've worked out all the bugs on those tractors, so you can pretty much just download the code and put it on your Arduinos in your own tractor, wire it up the same, and you should be ready to go. For the best results, you'd want to understand what everything's doing, because maybe there's some way I'm controlling the joysticks, or maybe my LEDs are different to the way you want your LEDs to do. So if you understand the code, it's very simple for you to change it, to add more servos, to talk to different trailers in a different way, to do whatever you want. This whole setup is completely customizable. You can do it whatever way you want. You can take my code and completely change it if you want. You can start from scratch, build your own code. You know, you've a huge amount of options. If anyone does come up with their own code and make some nice little tricks that are useful for their RC tractor, make sure and share them on the forum so that we can all benefit from them, and then hopefully we'll end up with a code that's perfect. I mean, I'm working on codes that will detect the battery voltage and shut the tractor down before the lithium-ion battery gets too discharged. Code that if the controller dies, the tractor will just stop. If it hasn't received command in a certain length of time, it'll just go into a standby mode. So if you can think of features like that I haven't included, and you're not able to figure it out yourself, you can let me know, and I'll try and sort that out for you if I can. And in that way we'll continually improve the code. So the code for this kind of stepping stone tutorial is on the forum, like I said, so you just head over there, you can copy that, and if you improve it yourself, if you can add the servo, you get the servo working with the single Arduino, then you post your code down in that thread, and then the next people coming along to the thread, they should be able to just copy your code and work from it. So in that way we just keep improving things. So that's everything to do with this. If you like that, make sure and hit the like button, And like I said, the code is on the forum and the wiring diagram is on the blog, so just follow the links in the description and you'll find all that information. That's pretty much everything, so thanks very much for watching.